Hello, everybody. Uh, I'm Mohammed Mazrullah Rathor, working as a researcher at Hamad bin Khalifa University, Qatar. I'm very thankful to Professor Dr. Sungmin Ro for his invitation to present a lecture on security issues in smart cities, the recent trends. At his course, The Recent Trends in ICT and Security at Chungeng University, South Korea. So before going to the actual topic, I want to just give the overview of my research area and my articles. And then I'll just briefly introduce where I live and about my university. And then I will move towards the actual topic. Basically, I work in big data, smart cities, including the different smart systems like smart homes, smart traffic systems, and other IoT systems. And also, the recently I worked on information security and different privacy issues in different smart systems, network traffic analysis, intrusion detection system, and machine learning. I have published more than 60 articles, and one of my article with the collaboration of Professor Dr. Rowe got the citation of more than 600, and this work was on smart cities and published at Elsevier Journal of Computer Networks. And overall, I have the citations of more than 2,500. Now let's move on to the where I live and about some few brief details of my university. Uh, I live in Qatar. That is the region in the GCC, in between the Middle East, and it's quite far from South Korea. And it looks like as South Korea because it is surrounded by the sea from three sides. But the population is quite low, just 2.8 million. And among 2.8 millions, there are 2.4 million foreign workers. So there are just 0.4 million local nationals. And the area is quite less, like it's 9 times lesser than South Korea. And the weather is quite hot even these days because it's all desert. And the university is one of the top university in Qatar. It is in the capital of Doha. Basically, it is established in 2010 as a technology university. Now, currently, they have the more than 1,000 students from around 57 nationalities. And we have 6 colleges, including the College of Sciences and Engineering, where I work. And we have 3 autonomous research institute where there is no academics, but top Qatar research work is being done there. And overall, we have 35 study programs, including 7 programs of related to engineering. So let's go to the now actual topic. Today we are going to discuss the smart cities and the security issues in smart cities and how we can cater them while developing any system in the smart cities. So initially we will discuss why we need the smart cities, and then what is smartness, and how we achieve a city to be a smart one, and then the role of ICT in developing smart cities, the overview of different smart systems that are part of this, that can be the part of the smart cities, like smart home, smart healthcare, smart grid, smart transportation model, and there are many other smart systems that can be the part of the overall smart cities, like smart agriculture, smart industry, smart manufacturing, smart turbines, like etc. And then I will discuss about the dimensions of smart cities, and one of the ideal architecture of smart cities that uh, we have proposed in our article. And then I will move towards the security side, like why we need the smart city to be secure, and what are the real security issues and the privacy issues in smart cities. And then I will discuss what are the security requirements that have to be achieved to make their cities secure, to make their smart cities secure from the intruders. And also I'll discuss what are the technologies we can use to achieve those security requirements. And finally, there are a few recommendations from our side to when the developer develop any, or the organization develop any smart city systems, they have to take care about these recommendations in order to provide the security to their systems. So now, first we can see why we need the smart cities, why we need the cities to be more smarter. You can imagine 50% of the world population now living in the cities, and it is increasing day by day. Today it's 50%, tomorrow it may be 55%. So because of this increasing population, the traffic flow problems in the cities is also increasing. There are more vehicles, there are more transportation in the cities, and it is also increasing on the same ratio as the rise in the population of the cities. And because of this reason, the pollution is also increasing, and it impacts on climate change and biodiversity. And the climate change may also cause of floods and weather events such as forest fires. And you may have heard about the recent events in Turkey, in Algeria, and Greece of huge forest fires. And it was very difficult for them to handle such huge fires in the current setup. And also with the increasing population in the cities, the authorities have very high demands for resources and service provisions to their citizens. So to cater these challenges, we need our cities to be more smarter, to be shifted from the current traditional setup, to introduce the digital technology in the cities, to make these cities very smart enough to handle all of these challenges. So now the world is moving to make their cities smarter in order to meet the current needs. And China, which is the most populated country in the world, has alone more than 200 smart city projects that are being developed. So you can imagine the importance of the smart cities with this statistics. Now we can have a look and understand more about the what is the exactly is the smartness and the smart city. We can simply define smartness as the ability to solve the problem intelligently, accurately, and efficiently. And we can define smart city as a city which has the ability of smartness that solves the city related problems that are related to government or with the common public or citizen, and the city that solves that problem intelligently, accurately, and also automatically, because since we are living in a digital era and the smartness can be achieved using the digital technologies, and it can be achieved using being done the problem uh, the solving the problem automatically. So the city that solves the problem intelligently, accurately, and automatically at a real time, that cities we can call it as a smart city. And that problem can be related to transportation, such as if a citizen want to go from point A to point B very efficiently, he can just find out the way at a real time. And the authorities can manage the increasing transportation at a real time. So the transportation problem, there can be a disaster management problem, health related problem, energy and resource management problems, challenges, and safety and security problems, and many such other problems. So if these problems we are able to solve these problems intelligently, accurately, automatically, and at real time in a city, that city we can call it as a smart city. There are numerous definitions for a smart city. Different persons define smart city in a different way. So let's have a look at different definitions. One of the researchers defined a smart city as a city that uses a framework of information and communication technologies to create, deploy, and promote development practices to address urban challenges and create a joint up technologically enabled and sustainable infrastructure. So he focused on the sustainable infrastructure with the technologically enabled systems. And the other person, he defined the smart city as a city that connects physical infrastructure, information technology infrastructure, social infrastructure, and business infrastructure to strengthen the city's collective intelligence. So he just adds the social infrastructure and business infrastructure with the previous definition. Now, such definitions may be very difficult to understand for a layman, for non-technical person. So that's why we define the smart city in a very simplest way. In our view, a smart city is a combination of smart systems in a city. What are those smart systems? Such as smart homes, smart agriculture system, smart industry system, smart building, smart transportation, smart healthcare. So the smart city is a combination of all these smart systems within a city, and these systems may be interconnected, or some of them may be interconnected to exchange the information, and these systems are collectively controlled and monitored by some central authority so that they can provide the facilities to the to the citizens at a real time, cater their demands, manage their infrastructure, and handle disastrous events such as fires, earthquakes, etc. So this is the simplest one. Now, after looking at the definitions, uh, you understand the basic overview of the smart city concept. Now, we can have a look at the role of information and communication technologies in developing smart cities. Information and communication technologies is the backbone for smart city. This is the main reason why smart city concept came into existence. If there is no ICT technologies, then there is no existence of a smart city. ICT facilitate in managing the cities in a way that citizen can be able to get access to all desired application and services. For example, I already gave the example of a transportation system where a citizen may want to go to his destination in a fastest way. So because of the ICT, it provides the smartness to the to cities. So the citizen can find out the quickest way to reach their destination, and this is just because of the advancement in the ICT technologies and the smart cities. And the usage of ICT in a smart city consists of four main phases. The smart cities can be achieved using these technologies in four phases. These four phases are provided by the ICT, different ICTs. What are those four phases? First, gathering information, like gathering the information from different smart systems. Because if you have the information, you can make the decisions. You can facilitate your citizens. For example, transportation related problems, you have the real time information of traffic flow, then you can facilitate the citizen for their quickest route. So gathering information is important, and ICT provide this facility of gathering or harvesting the information using the IoT devices and IoT sensors. Using those IoT devices and sensors, you can collect the data, and also using the social networks like Twitter, Facebook, WhatsApp, etc. So there are a lot of other like harvesting uh, technologies that the ICT is using to harvest or gather the information from different smart systems, using different wireless technologies, using different communications. And the next phase is data storage. If you gather the information, next phase is storing the data. Because there are a lot of smart systems, smart homes. There are thousands of smart homes in the city. There are thousands of vehicles running on the on the roads, and you can imagine the data that are being generated by these sources. So it would be very huge. It can't be stored in a TB in a TB's hard disk. So we need a special kind of infrastructure to store them. It can be central or a very huge server, or it can be distributed around within the country or around the globe, or on a central cloud storage. So we need very huge setup to store their data, and to access that data efficiently, because that is very huge. And if we need a particular information, we need the fast access mechanism to get the particular information from a huge pool. So we need such technologies, such algorithms to retrieve that data. When I say cloud, it means the data on the internet, on some public or private server that is accessible from anywhere in the world. I will not go to more details on the cloud, but you can just imagine the data on the internet, such as on Google Drive or any other public drive. Now the third phase is decision making. When you have the data, now how you can make the decisions. So there again, there are different algorithms, AI and machine learning techniques, statistical analysis, mathematical modeling, graph theory to make the decisions based on the current real-time data. So this is just because of the ICT technologies and the recent uh, the recent analytics techniques. Thanks to them, that they provide the efficient decision making power to the system. And finally, the dissemination of information. The communication technologies such as satellites, wireless technologies, and the other cellular technologies like similar, definitely we have very huge amount of real-time data generation. So we need very fast technologies. The current technologies may not be able to cater the demands. So that's why we need advanced technologies to meet the current challenges. And thanks to ICTs, that the technologies is being advanced every day. So we are meeting the current challenges. Now, let's have a look at some of the smart systems that can be part of a smart city, and mostly they are part of this of a smart city. So we will just have an overview of few of them, not all, to understand the more details about a smart city. So let's start from a smart home. Basically, smart home is a combination of sensors and actuators, along with some admin device and a central server or proxy server. So what sensors do? Sensors sense the information, and what actuators do? Actuators behave based on the sensor information. For example, sensors sense the information, like sense the when a person enter into a house, sensors sense the information. There is a temperature sensor that sense the temperature, and the AC, smart AC can work as an actuator. So when the person enters into a room, it is sensed by the sensor, and the signal is received by the actuators, that is AC or smart light. So they are turned on. The actuators are turned on. AC may be turned on, or smart lights may be turned on. So there are different sensors and actuators in the smart home, like smart locks, smart refrigerators, smart temperature sensors, smoke sensors, smart meters, and actuators like smart lights, smart ACs, smart TVs, and security cameras. And there may be some wearable devices, like, for example, you put something on the kids' clothes to monitor their activities. And all these sensors and actuators are controlled and monitored by some owner's device called admin device. And this all of this data or some of the data may be transferred to the some authority or some central server. For example, if your home is equipped with smart metering system, so the smart metering your daily consumption of water, electricity, gas is sent to the smart grid or electric server in order to for the dynamic billing. Or some it can be sent, some of the information can be sent to the fire brigade when there is a fire in the house, like temperature sensors reading or smoke sensors reading to the fire brigade station or the police station in order to allow them to make quick action when there is any fire event. And there is also a smart healthcare system in a smart city where everything is connected. The doctors and the citizens are connected on a system uh, to make it more easier for a citizen to search a particular doctor and provide the real-time healthcare to each of the citizens, especially for the elderly people or some the patient with a chronic disease. In a modern system, the elderly or the kids or the chronic disease person, they may be equipped with some sensors technologies or some medical wearable devices that are attached to their bodies in order to monitor their health real time, such as their their blood pressure, their sugar level, or their heartbeat or pulse rate, etc. And these real-time readings are sent to the some central hospital, their hospital or their doctor who is monitoring them at real time. And if there is any serious event, for example, their heartbeat is quite low or and their blood pressure is lower than a particular serious threshold or higher than serious threshold, it can generate alarm to their doctor or to their hospital or to some emergency center so that the emergency services can be provided to the citizen. And there are a lot of other complicated stuff. I will not go into the details. Uh, so let's have a look on another smart system, that is smart grid. Since traditional energy grid infrastructure doesn't meet the growing needs of communities, the traditional system couldn't manage the workload. So we need some smart system like smart grid that manage the load based on the needs of different communities. For example, if one of the region require lesser power, so the lesser power should be provided to that region, and one of the region, for example, the industrial area that needs the more power, so we the grid have to send the more power to that region. And uh, the all the energy the energy from all the sources like uh, from the from the turbine, from the solar plant, from the water turbines, all the energy should be aggregated on one grid. So this can be provided by a smart grid. In a smart grid, there is a two-way communication from grid uh, to the to the home or to the industry or to the customer. The electricity is provided through the traditional lines, traditional electric lines, and the data from the other end is sent from the inhabitant or client to the smart grid in order to look at the daily or routinely energy consumption. So smart based on the data received from the clients, from the customers, the energy is managed by a smart grid. And the energy can be predicted, the energy consumption can be predicted earlier. For example, what would be the need for today? So we have to generate that amount of energy in order to meet the tomorrow's need or for next month's needs. So that the energy can be predicted based on the current consumptions. And also the smart metering, due to the smart metering, the billing can be dynamically done at the customer sites, and the tariff can be managed dynamically based on the peak hours. The tariff on the peak hour, the tariff would be more. So on the when there is no peak hour, the tariff would be lesser, in order to encourage the inhabitants to reduce the energy consumption at the peak hours. Now have a look at smart transportation system, where the vehicles are interconnected, send the information to each other, like their location, their speed. Especially in the driverless cars, there's a lot of communication between vehicle to vehicle, uh, and also the vehicle infrastructure is also uh, connected with the other systems, such as if there are electric vehicles, when they charge, their charging system is connected with the smart grid. And the lights on the street, they are connected with the smart grid. And similarly, there are other systems, they are interconnected with the smart home and the smart grids and other central city systems. And particularly in the smart home, there are two ways to collect the data. One is vehicular network, and the other is road sensors. The data is collected from the vehicular network using the cars itself. The data is collected using some receive side units, the car speed, the car location, and other information is sent by the car itself to the central authority or to the central server. And the other way is to collect the data using the road sensor. For example, on the junction, there is a camera is installed, uh, which is collecting the number of vehicle passing by that camera, and collecting the information of speed and the number plates, etc. And there may be another sensors like a road sensors, who is just a counter who counts the number of vehicle passing by that sensor. And such type of traffic flow data is sent to the central server using the IoT infrastructure. Definitely there are different type of networks involved in the road sensors and vehicular networks and any other network. So there is a need of gateways, coordinator nodes, relay nodes to send those data over the internet to the central building. And the central building, there are different complicated algorithms are involved, and there is a very huge system is required to analyze that huge amount of data in order to provide the real-time decisions to the inhabitants and to the authorities. That decisions can be related to traffic management, for the travel guidance, such as the quickest route or road blockage or accident, etc. And we can also do the urban planning based on this historical data. And yeah, these are four basic smart systems that are normally part of the smart city. There are a lot of other smart systems like smart agriculture, smart industries, smart parking, smart retail shops, and many other smart systems that can be part of a smart city. Now let's have a look at the dimensions of smart cities. that are defined by one of the researcher. That overall, what are the dimensions of the smart cities? That what type of smart system that can be involved in a smart city. So these are the 6 dimensions of smart city. Every smart system belongs to every object belongs to these dimensions. The first one, smart governance, where private, public, civil organization, infrastructure, government and utilities are involved, such as smart retail system, uh, the government departments are involved in that, the fire system, the police system that are involved in that. And then the other dimension is smart people, where the people are with the skills, with the wearable devices. They are interconnected with the digital technologies, digital infrastructure, digital smart systems. And then the third one is smart economy, where e-business, e-commerce, production, retail shops, smart factories, smart industries, smart manufacturing, smart agricultures are involved. And the fourth one is smart mobility, where transport, logistics system, traffic, and also the people who are moving here and there with the GPS technology. They are involved in a smart mobility, different smart mobility systems. And there are smart livings, where classy lifestyle, reasonable consumption, stable behavior, and the homes or streets, the such type of style is involved, and their way of living is involved. That is also part of, even though it's not digital, but that is also part of uh, of a smart cities. And then smart environment is there, where smart home is there, smart buildings are there, smart energy system is there, smart water and waste system is there, smart health is there, clean environment is there, control pollution is there. And there are a lot of other systems that can be part of the smart environment. So every smart system is part of one of the dimension. So any systems we are developing as a smart system and connected with the city system is part of one of the dimension. Now we can have a overall overview of a smart cities, like as already I already described. There are smart industries, smart security system, where the IP cameras, security cameras, city cameras, traffic control cameras are involved. And there is also smart retail shops. There is also smart societies, where the people are connected with the digital infrastructures. They are collaborate with each other. They are connected with each other using some social networks. And there is also communication infrastructure. There is also healthcare system. There is also smart homes. There is also smart energy system. There is also smart mobility system, where the trains, public transport, buses, and even the people are involved. So all of these systems collaborate with each other in order to establish a complete smart city. Now we can have a look at an ideal smart city, where the data is harvested, where the data is collected using the smart systems and IoT technology. So there are the data is the harvesting systems are smart systems, such as environmental and pollution system, vehicular traffic, weather and water system, smart parking, smart home, surveillance and safety systems. And there are a lot of other systems that can be part of a smart city for the data harvesting. And each of the system have their own protocol, have their own network configurations, have their own communication infrastructure. So every so they are heterogeneous. So we need a simple, we need a common, a central system that can merge all of these heterogeneous communication and send them on a single homogeneous channel. So we need in an ideal smart city model, we need a central hub, data hub, which collects the data from heterogeneous systems and generate a homogeneous data and send over the internet to the central building. So that can be this central data hub can be collection of gateways, can be collection of relay nodes, coordinator nodes, central servers, and other technological server, and send the data over the internet to the central building for the analysis. And if we go into a deep discussion, there are system smart data sources that sends the data over the gateway to the intelligent building over the internet. At the intelligent city building, we named it as a intelligent city building. That can be one building or one server or multiple server or distributed server. So there they have very complicated algorithms, complicated communication and computation technologies, and very efficient powerful technologies to handle those incoming data in order to perform the real-time or real-time decision or future planning. So the data is collected. There may be a separate one data collection unit or multiple units that collects the data from multiple sources, from thousands or millions of sources. And it should be efficient enough to take the data from that overwhelming sources. And then that data should be filtered out so that all the unnecessary data or metadata should be discarded. And only the important data should be sent for the processing or for the storage. And then the data is processed using some data classification techniques or some other parallel processing techniques like soft computing, decision models, machine learning, threshold based computing, and other statistical models and other complicated algorithms to make the decision related to citizen, related to government authorities or any other community like businessmen. And there we need some parallel processing technologies, parallel processing hardware technologies such as Hadoop, Spark, and there are tons of other technologies that provide the efficient processing. And that decisions can be related to smart city planning, disaster management or disaster response, event detection, energy, some kind of energy management, resource management, or transport related decisions, or giving the efficient or fastest route to the citizen, or alerting the citizen for the when there is more pollution on a particular area to alert them not to go out, such type of decisions for the citizen. And there may be some real-time city monitoring for crimes, and maybe the profit maximization suggestions or recommendation to businessmen or some other community. So overall, there are two types of decisions are made by the city system. One is real-time smart city decisions, and the other is planning for the future, such as road infrastructure planning, energy energy consumption planning, like what would be the demand for the next day or for the next month or for the next year. Such type of plannings are part of a smart city. Now there are four layers of overall smart city architecture. We have seen the model, but when we divide the overall system into different layers, there are four basic layers. It depicts the the role of ICT we have discussed, the phases of 4 phases of ICT we discussed in our initial slides. So it is the same, almost same concept, same, it depicts the same layers. It depicts the same phases. These layers depicts the same phases. The first one is perception layer, where the data is harvested, the data is collected using smart systems, using IoT devices, sensors, social networks, and other data sources. And definitely that there is a communication. The data is sent over some communication channel to the central server or distributed server or multiple servers, or there is also communication in between data, in between devices, and also in between smart system. So at the network layer, the communication infrastructure is involved. That can be wired or wireless networks, satellite networks, cellular networks, 4G, 5G networks, etc. And then the third layer is the support layer, where all the computation is done, the storage is done. That can be over the cloud, that can be over the fog computing. I will not go into the details of cloud and fog, but it can be over the internet or central server or personal server or private server. And there are very like complicated algorithms are involved, complicated techniques are involved, such as soft computing, machine learning, AI techniques, deep learning, statistical modeling, mathematical modeling, etc. So based on these models, the decisions are made, and their decisions are related to any application such as healthcare, uh, energy consumption, or related to generating an alert to the citizens or to the authorities, related to smart agriculture, related to transportation system, or related to traffic system, related to some kind of environmental stuff. And there are millions of decisions can be provided by a smart city. Now let's move to the security side of the smart city. Why? First question is why we need the security to a smart city. In a city, like when there were a traditional city, there was no communication is involved between smart system. There is no existence of smart system. There is no existence of communication over the digital channel, and there is no concept of data storage or a public network. But now there are different data sources are involved. There are different smart systems are involved. They are communicating with each other. They are communicating with this some central or distributed storage over the internet or the public internet. And similarly, the users are are taking the facilities from the city server or a public channel or a public internet. So if the data is not secure, it can be disastrous. For example, I gave the example of I gave the example of a smart grid. When the communication between the user and let's first take the example of a smart home. When the communication between the smart home and the central server is not secure, for example, the smart home is sending the signal that there is a fire in a smart home, or there is a fire in a factory, to the fire station. But there is an intruder, there is an attacker in between, and he captures that information, and he is your rival, and he just forged the data and send the signal that there is no fire. So you will not provide the immediate action from the fire station, even if there is fire. So there are a lot of such attacks can be performed. if the data is not secure. So there are privacy issues as well. For example, in your home, if the data is not secure, your IP cameras are not secure, your CCTVs is not secure, so the attacker can have access to them and can monitor your daily routine when you are at home, when you are not at home. So when you are not at home, he can steal something from your home. He can damage your home. He can even he can increase your temperature level. He can play with your devices. He can play with your refrigerator, your temperature sensor, and forge the data. And there are many such events have been occurred in the world that have very disastrous results. So securing the communication and the data, and also the object itself, is very important. So there are requirements of authentication, integrity, confidentiality, availability, and privacy in order to secure the smart city. We will discuss the details of these security requirements in a smart city in the later slides. But you must know that providing these requirements is very necessary when you develop any smart system in a smart city, or when you launch any project for a smart city. So now we can see the security issues. What are security issues are raised just because of unsecure smart city system? The security issues can be raised in any of the four layers we have discussed. It can be at the perception layer while collecting the data. It can be at the network layer while communicating the data over a public channel or a wired or wireless network. It can be in the computation infrastructure, or it can be at the application layer. And you can when there is more digitization, more automation, data is over the public networks, data is communicated over public communication channels, and the objects are connected, and data is stored on a central or distributed storage, which is also over the internet, also can also be public. So these type of things results into more chances to cyber attacks, because if they are not secure, there is more vulnerabilities. There can be more loopholes, because everyone have access to the channel, everyone have access to the storage, everyone, maybe someone have the access to the someone or everyone, or some of the group have access to the objects. So they can intervene and exploit those vulnerabilities in order to get illegal access to the system and can launch attack. Previously, because the cities were not smart, no digitization was there, no communication was there, so there were very less possibilities of such attacks. So there is no possibility of such cyber attacks, because digital infrastructure were not involved. But now digital infrastructure is there, so by default there is the possibility of cyber attacks. And compared with the computers, IoT devices are often designed with poor securities or even none at all, because the computers are very powerful. So you can equip them with the powerful security algorithms, but the IoT devices and IoT objects are less in power. They have less processors in power. They have some of the sensors doesn't have the connected power supply, and they have very less memory. So when the manufacturers manufacture such objects, They put some default configuration without the security or very poor security. So because of that reason, the people don't change those security configurations. They just um, put them as a default. So this is the vulnerability. So the attacker knows about these default configuration. They exploit them and intervene into the system and launch the attack. And if there is any vulnerability or loophole in the smart system or in a sensor or in a one object that is connected to the system, it will violate, it will destroy the whole smart city system. So it is very necessary to secure not only the channels but also individual smart system and smart objects. The vulnerability action of individual or organization or smart system or, or an object can put the entire city at risk. So we have to resolve these security issues while designing or developing any system for a smart city. So what are these security issues? The most popular one is the denial of service and service disruptions. The, the statistics shows that most of the attacks launched are on the smart cities are denial of service. For example, there may be electricity breakdown because the smart grid is connected with the digital world. There is a communication that there is a communication. The smart grid is managing the energy based on the current needs. So it is connected over the digital world. But what attackers can do to perform the denial of service attack or service disruption of the smart grid, he can attack the launch, he can compromise and spread the virus and compromise many nodes and send the illegal requests to the millions or billions of illegal requests to the smart grid. So smart grid would be busy in handling them, and it would be that overwhelmed that the smart grid would not be able to perform its own operation, that is the distribution of electricity. So there would be electricity breakdown. There was an incident in 2015. Nearly 230,000 citizens living in Ukraine suffered a long period of electricity disconnection just because the power grid system was attacked by hackers. And there is also another example in a traffic scenario where the traffic lights are controlled and automated and controlled by the traffic control system. And there is a communication between traffic lights and traffic control system. What attackers do? Attackers can intervene and compromise the lights because if they are not secure, they can forge the data and change all the lights to red. So no one can pass into the from the junction. So every vehicle will stop. There will be a disruption of traffic, and it will send this OK signal to the control system that every traffic signal is performing well. But in reality, the attacker has compromised the lights and made them as a red, so no vehicles can pass. So overall, it would be a like a disastrous effect on the overall traffic system in a city. So that mostly that denial of service attack is performed using the botnets, and mostly it is distributed denial of service. Distributed in that sense, that denial of service is performed by thousands and millions and billions of compromised nodes. So it is launched distributedly using the botnet. What is the botnet? In the botnet, there is a one root master, that is the attacker. He has the command and control server. He compromised one of the server, one of the node, or he can just create his own on server that launch the attack. He hide them back of that servers, and he launched the attack on worm virus that spread across the different computers in the world or in the city. That command and control server identify the loopholes in existing computers. For example, one of the computer, if there is no password, or if there is a weak password, or he sends some link to the person, and when the person open that link, the worm is spread and it affects your computer. So, so that command and control server identify the loopholes in the existing live nodes, live computers, and launch the attack. So these nodes are, some of the nodes are compromised, and they behave like a zombies. They also send their worms to other computers, and then those affected computers send the worm to the other computer, and so on. So it would be a very huge network of bots. We call these compromised nodes as bots or zombies. So that millions and billions of those computers send the signals to the victim server. For example, I gave the example of smart grid. So that compromised nodes send the signals to the smart grid or other victim nodes. So victim nodes, when get the request from billions of nodes, so it will be busy in handling them. The server will not perform his own duties. So the server will not give the services to the legal clients. In the smart grid, the grid will not provide the electricity to the consumers, to the factories. So there would be a electricity breakdown. And another case, in the transportation department server, if the attack is launched, the transportation department will not perform his duties, and there would be a disruption in the overall city traffic. So there are a lot of examples we can quote for the distributed denial of service attack. So this is the popular one. So if we remind the concept, botnet is basically a number of interconnected devices and running on one or more bots. DDoS, distributed denial of service attack, is performed through the botnets. I already told you. It steals the information, allows the intruders to access the device and connection. IoT bots have posed serious threats to IoT systems. And there is another example of Mirai botnet. In fact, devices like IP cameras, webcams, routers, etc. spread infections to many heterogeneous IoT devices and cause a DDoS again target servers. There are many other such bots that have performed the attack on different servers. So you can just Google different botnets. You will understand that what type of attacks they had launched. So now, other than the denial of service attack, there are other security issues such as eavesdropping and surveillance. It can be done by some foreign intelligence agencies or even the local agencies to just monitor the activities of their own citizens, or eavesdropping the communication between smart systems or within the city systems. You can imagine if the communication is not secure between some critical smart systems such as transport, the security system, then some other agencies, even your rival agencies, can monitor that the activities of your legitimate citizens. I will recommend to you to watch the Snowden movie, where the person Snowden, he is working in an intelligence agency, and he revealed how the agency uh, violate the violate the privacy of common citizens. And there are a lot of other hacking system examples where the serious concerns of securities lies. If the system is not secure, it can be hacked. For example, there are energy or manufacturing plant system where if the attacker can like launch the attack not only to for the eavesdropping, for just damaging the system or the objects in the manufacturing plant. He can forge the data. He can just like results into the manufacturing of faulty parts. And in the transportation system, he can intervene into the communication, especially in the autonomous cars. When the cars are communicating with each other, he can change the communication, and that can lead to accidents. And there is also uh, the possibility of hacking the communication channel and the medium communication medium such as satellites, wireless or wired networks, hacking into the financial and banking system, hacking and violating the privacy in smart home and building. For example, forging a customer identity uh, by an by an attacker to to have access to the building. And I already gave different example of privacy violation in a smart home. And also, it is also possibility to hack the IoT objects, IoT devices, by forging them to detect, for example, forging the sensors to detect earthquake, flood, shooting, etc. And yeah, such forging can cause erroneous warnings or cause public fear that can be a motivation for the attacker. Overall, there are also security concerns in the overall communication that has to be considered while designing a system. The most important concern that the public have the fear about is the privacy issues, which are more important for a citizen, as a citizen in a smart city, because in a smart cities the authorities or service providers are taking your personal data. For example, in case of a smart home, they are taking your sensors reading. They are taking your daily consumption of or routinely consumption of your power or water or other stuff. And they may also have the access to your security cameras as well. So it violates the privacy, especially in case of third-party service providers such as Google or Intel or any other. There are a lot of service providers that are providing the devices for your to establish the smart home in your building. So they have access to your private information. Let's say when you watch the TV, what is the temperature of your room, how much is the consumption of your electricity. So such type of data is sent to the service provider. They have access to it. So it can leads to the theft of personal data that can be sold to the third parties if you don't have an agreement with the parties of with the authorities. They can sell your data, and it can be illegally used. And in a worst case, there are ransom attacks where the parties, the attacker have access to your personal data and ask you for some money that against that he will not reveal your personal information to anyone else. So the attacker asked for some handsome money and offer you that he will not he knows your data, but he will not reveal it to your rivals, especially in the business perspective. And there are very serious issues in privacy issues in the health sector, where the health data of all the citizens are stored, and also privacy issues in smart homes. I already discussed privacy issues in the smarter transportation system, where the trajectory data is captured by the transportation authorities, and also some navigation systems such as Waze and Google. So the person who have access to that data can draw the trajectory of particular person or particular uh, vehicle. So he will know what is the routine of a person, where he is going every day. Like such type of private information can be revealed to these parties. Overall, citizen privacy in mobility application is also revealed in such application like Google Maps, or Google navigation system, or Waze navigation system, or any other navigation system you are using, or any other application you are using which is accessing your location data or any other data. So these are serious privacy concerns that have to be considered while designing any system for a smart city, because the user privacy is very important, and it is becoming a serious issue in the future. So to cater these security requirements and privacy requirements, there are security requirements that have to be fulfilled while designing any smart system or any system for a smart city. First one is authentication. To solve this, to solve the security and privacy issues we discussed, we must have to accomplish and regulate these security requirements. The authentication allows only the authorized objects can communicate across a heterogeneous system. Mean if there is an attacker, or if there is an intruder, he want to communicate with any system, or with this smart city system, or with any object, or with any smart system, then he only can communicate if he is authorized, if he is legitimate, if he is legal person. If he is not legal, he should not be allowed to communicate to the other party or to the server. And the overall network should also be authenticated. Other nodes and even the messages should be authenticated, whether it is from a legal entity, not from the attacker, not from the bots, or not from any other any other illegitimate entity. And this authentication can be achieved using the digital signature mechanism, hashing, message authenticate, a message authentication code, biometric, and there are a few other tools that can be used to achieve the authentication. I'll not go to the details of this solution, because every solution require a separate lecture to understand. And then the next is the confidentiality. Confidentiality is that your information is not revealed to the attacker. It should be secret. Like if when you are communicating, when the smart system is communicating to the central server, in between, if anyone have the access to the channel, if he capture the information, he should not be able to understand it. It should be encrypted, it should be in a hidden way, and should not be exposed to the wrong source. And that can be done using the encryption mechanism or watermarking or steganography or any other mechanisms. It is based on the requirement and the capability of the system. And the third requirement is the integrity of the system, integrity of the message, integrity of the overall system, that provide a protection of data from the data tampering, that in between the communication or on the server, no one can tamper the data. If anyone tamper the data or forge the data, it can be identified. So you are providing the integrity and a surety that the data is not changed during the transmission or on the system. That can be achieved using the hashing, HMAC, watermarking, etc. And the fourth requirement is availability, that the services should be available to the all the legitimate users. Like there should not be any denial of service attack. If there is any attack, your system should be able to detect it, tackle it, or avoid the distributed or normal denial of service attack. And that solution can be achieved using the intrusion detection system, strong intrusion detection system, and the firewalls. And the final is the privacy protection requirement, that if you are developing your system and you are capturing the data, the privacy of the smart homes, the privacy of the citizens, the privacy of the authorities should not be compromised. Your data should be stored in such a way that even if anyone have the access to that data, he cannot perform any illegal activity or cannot use that data for the illegal use. That can be achieved using the homomorphic encryption, differential privacy, anonymous mechanism. We are using this homomorphic encryption, differential privacy, and anonymous mechanism, the authorities capture the data in such a way that they perform their tasks, but the data is not revealed to them. So there are ways, if you want to know more about the homomorphic encryption, differential privacy, or anonymous mechanisms, you can just see that the tutorials of these concepts. So all of these security requirements we have discussed can be achieved using different technologies. These are the technologies that provide the ways, different ways to achieve those security requirements. The first one is cryptography. I talk about like signature mechanism, encryption mechanism, hashing, and these type of things that comes under the cryptography. So confidentiality, authentication, integrity, privacy using homomorphic encryption, these can be achieved using the cryptography. Traditional crypto systems are very slow, so that may not be very feasible for the restricted environment, like in the IoT environment, where the devices have the limited power, limited memory, and limited processing capabilities. So the computational complexity and energy consumption problems may arise if you are using the traditional crypto system. So that's why we need the lightweight, very efficient efficient cryptographic ways to provide those security requirements. And research is going on this direction to provide very lightweight and efficient and secure mechanism for the smart city in order to provide them in order to meet the requirements of the low power devices. And the next technology is the blockchain. Blockchain is just the storing the data on a distributed on a distributed network in the form of blocks, and each of the block is interconnected, and there is no possibility of changing the history data or previous data, because it is infeasible to change the overall any block in the blockchain, or overall any transaction in the blockchain. So using the blockchain, you can achieve the authentication, integrity, secure data storage, uh, wide the accessibility of the data. Everyone can access the data from anywhere because it is of distributed nature, and you can track the transaction history, previous history. You can use the blockchain technology for a smart home, for vehicular communication system, and many other systems. And another technology is the biometric, like thumb impression, face impression. But some these technologies are very expensive. Now people are using the brain waves based authentication, using the EEG readings, where EEG signals are used, and they are very unique and very complex and very efficient to process. And using the biometric, you can assure the authentication and access control. And also the machine learning and AI techniques are used to ensure the availability, to avoid the intrusion, to avoid the denial of service attack, in order to detect the intrusions. And there are also, they provide the mitigation strategies using the machine learning techniques. So these were the technologies that can be used to achieve the security requirements we have discussed here, like authentication, confidentiality, integrity, availability, and privacy protection. Now there are a few other recommendations that should be take care by the developers and by the researchers when they design any system in a smart city. You know that traditional security system methods are not sufficient for the smart city environment, because of they are very complex, and IoT devices are low in power. So we have to design a communication security system that is fast, efficient, and real time, and there should be no delay tolerance, because it should be efficient enough to meet the needs of uh, the data is coming with a very high speed, and it is of very big nature. So it should be efficient enough that it should not introduce any delay in the communication, and also handles the data from multiple sources, from heterogeneous sources, uh, and with a very high speed. And also the citizens should also be aware of utilization of resources and IoT devices. They should have to change the default configuration when they deploy the devices or sensors within their environment or smart home. Um, Citizen privacy should also be taken care of while designing a system. You should have to use the homomorphic encryption, differential privacy, and anonymity in such a way that the goal of the authorities or third-party servers uh, can be accomplished while achieving the privacy of the user. So this was just all about the smart city and the security issues. And these are some references that I quoted in my presentation. You can have a look, and if you want to read more about them, you can just download these articles and read about it in more details. And if you have any question related to any concept in the smart cities and securities, or security in general, you can just leave me an email on my email address mrathore@hbku.edu.ua. So thank you for listening this long lecture. And again, I am thankful to Professor Dr. Singmin Ro for to provide me this opportunity to present this lecture. Hopefully, I'll look forward uh, to have a question from you in on this topic. Thank you so much.